Operating a plant isn't an easy issue. It needs continuous monitoring of process parameters, checking equipment status, and fast response to solve the issues. In addition, the plant is prone to various hazards and upsets that can arise anytime. These hazards can be related to the whole plant or to a specific system. For example, while the plant is operating, power failure may occur, and this means that all rotating equipment shall stop, and this shall lead to catastrophic consequences. For example, consider what could happen if all air coolers failed or cooling water system failed due to cooling water pump malfunction, which means that water coolers are not functioning anymore. Can the downstream system handle the high temperature, or does this pose a significant risk to the system? Another example can be related to the failure of instrument air system. Through the instrument air system, which powers the actuators of all plant control valves, if this instrument air system failed, all valves shall go either to the open position or to the closed position. For example, what if the valve at the pump discharge failed in the closed position? It may be due to a false reading or mechanical failure. The upstream pressure shall increase. Is the upstream system ready for that pressure? Or what if the valve controlling the flow from a high pressure system to a low pressure system failed in the open position? This means that the valve is at 100% opening. How shall this excessive flow affect the downstream system? This shall cause overpressure in the low pressure system and may lead to severe safety issues. We may also have upsets related to the system itself. So, if we are having a vessel from where the pump draws liquid, if the pump stops or fails, the fluid shall accumulate in the vessel and may cause vessel overfilling, which can be a safety issue. So we should study this scenario as well. If we have a pump and there is a manual valve on the discharge, an operator closed this valve by mistake. The pump shall keep pushing the fluid into the closed valve. Is our system ready for such a scenario? Would this cause damage to the pump or to the discharge system? When we study the P&ID of our plant, there could be hundreds of upset scenarios, and we should take into consideration all these scenarios. Our plant should be equipped with the required protection to prevent these upsets from turning into accidents or equipment damage or even catastrophes that may cause losses of lives.